Hello and welcome to our special program of Science Series. Today we are in Nainital in Aryabhat Research Institute of Observational Sciences. Now this is a place where we have a number of telescopes wherein the renowned scientists who work out here go ahead and do their research on the science of astronomy, which is the science of celestial objects. Today's topic of discussion will be about astronomy as well as one coveted project in which India is closely involved with other 4 nations, that's China, Japan, US and Canada, and that project is known as 30-meter telescope. We also have with us a number of audiences, very starting from young students, there's school students to the research students as well as some college students as well. On our panel today, we have Dr. Wahabuddin on my right. He is the acting director of the Aries Institute. And then we have Dr. A.K. Pandey. He is a senior scientist and optical astronomer. We also have with us Dr. Shashi Bhushan Pandey, another optical astronomer from Aries. He is also closely involved with the TMT project. And the young man on my extreme right is Mr. T.S. Kumar. He is an electronics engineer and he is very closely involved with the TMT project. We'll also get to know as to how youngsters like him are playing an important part as far as the TMT project is concerned. Let's begin our discussion with Dr. Wahabuddin and let's begin it with a very basic question. Dr. Saab, what is the science of astronomy? The newest form of science. What is it actually about? What are we looking at?
Actually, astronomy is nowadays very important field and very vast field and most expensive field, we can say. We study the solar and stellar and other galactic, extragalactic object, and for those studies we need very advanced telescope. And because technology is increasing day to day, so if we have modern telescope and large telescope, then we can address frontline research in astronomy, astrophysics.
So basically, you mean to say that it's about trying to find out as to what exactly lies in the horizon out there. What is it about the stars, about galaxies? Can we also say that it's the science wherein we are trying to find out as to is there anyone else in the universe other than us?
This is a very good question. We cannot say that we are alone, and there are so many projects. One is called SETI and such intelligence. So, for example, the other stars, they are quite far. The nearest star is our sun. Some stars, they have planet in habitable zones, but the question is
does it really exist? And that's what we are trying to find out.
Actually, if suppose some planet which is quite far, suppose 100 light years, so if we send signal, it will reach in 100 years.
Okay.
And if we get a response, it will again take 100 years.
Yeah, that's
so 200 years.
So that's what the science is focusing on. Dr. Pandey, I'd like to bring you in, Dr. Anil Pandey. Can we also? It is also being said that 70% of the composition of entire universe is dark energy, and the 70% of the rest 30% is dark matter. And when it's being measured in terms of light, for example, the sun which we see right now was actually the sun 8 minutes ago.
Yeah.
So is it true that the kind of progress which we have made in this field of science is very minuscule? We will have to speed up a little more.
Yeah, you are when you say that 5% of the matter is in, you can say, in a visible form, remaining 75 in the 25% is in the dark matter and remaining is the dark energy. For example, the dark matter, there is lots of matter which we cannot see. For example, there are if you see our solar system, then we have planets and satellites, and similarly in other galaxies also we have some for example in the nearby galaxy Andromeda, which is our nearby one of the nearby galaxy Andromeda, we cannot see all the matter in that galaxy, but there are some special events when we observe one star, and when we are observing that particular star, then there is a variation, or there is all of a sudden there is a dip in that light of that star. So we can identify that there is some matter has crossed just before that the line of sight of our observation. So in that way we can say these techniques are known as the gravitational micro lensing sort of techniques. So with the help of these techniques we can search the unseen matter in the universe.
But then there are a number of questions. There are a large number of questions which are yet to be answered, and which I'm sure that senior scientists like you and your colleagues would be looking for. And I'm pretty sure that the audience will also have a large number of questions which will have to be answered by you. Meanwhile, let's bring in Dr. Shashi Bhushan Pandey, and this time around let's talk about the coveted project of 30-meter telescope, the TMT project. My question is, why have a 30-meter telescope? What's the need?
Okay, so the need for 30-meter telescope, as it is clear from the number 30 itself, that the existing biggest telescope, optical infrared telescope, is 10-meter class telescope, and with 10-meter class telescope the scientific requirements, whatever we want to know, is actually not fulfilled. And once you go from 10-meter to 30-meter, then definitely your light gathering power is increasing enormously. So the whole idea is to increase the light gathering power, so that you can have observations about the faintest object which you just cannot understand using existing facilities as of today. So if you want to know frontline research areas where there are many open questions, as we know, if you want to answer them, then definitely you have to have a large aperture telescope, and that's what the 30-meter telescope is.
So basically to increase our reach into the universe, to try
far
and,
away universe,
being able to see a little much more objects which are much more farther away than
much
the
more
present
fainter
ones.
Yes.
Okay, great, wonderful. You use the word instrumentation and kind of information which I have with me. Let me bring in the young man who is there on the panel with us, Mr. T.S. Kumar. Is an electronics engineer. You're the man who is involved very closely with the back-end instrumentation as far as the TMT project is concerned. Please tell us, what is it all about? What is back-end instrumentation? What is it that you're working on? What is it and how is it very important for the TMT project?
Yeah, actually this to utilize the data, the information being gathered by this large telescope, we need sophisticated instruments which can use that data and give us useful information. For example, imaging. So like you have digital cameras with you, so to image the sky we need a large format cameras. So this is one of the instruments, and also to analyze the spectrum, that is light, which can be split up into spectrum, we need spectrographs. So these are the key instruments which will be used for this with this telescope in optical as well as infrared region. So as of now 8 instruments would be there with this telescope, out of which 3 will be the first light instruments. That means these 3 instruments will come along with the telescope.
Let me once again go back to the audiences. In the meanwhile, if someone would have come up with an interesting question. Yes, anyone please? Come on guys, yes, very good. Can we have the mic please? Yeah, we'll pass on the mic to you and then you can ask your question.
So would you like to elaborate about the TMT, as what is the technology it is using, and I heard about that that it is using hexagonal mirrors.
Very right? Interesting question. Dr. Shashi Bhushan Pandey, straight to you.
So I'm asking that hexagonal, why that kind of shape is needed? Why not square? Why not triangle? That is the question.
Yeah, why keep the shape of the mirrors hexagonal?
Yeah, so as you know that 30-meter telescope is basically the primary mirror diameter is equivalent to 30 meter, and that 30 meter has been achieved by using 1.44 equivalent diameter, and 492 such segments have been put together to get the equivalent 30-meter diameter. Your question is precisely related to that, each and every hexagons, why they have put in a hexagon fashion. So the main reason behind putting it in a hexagon fashion is that you do not want to have gaps within the segments first of all. That you can also get by putting them in a triangular or in a square fashion, but putting them in hexagon is making a little more kind of balance and the kind of accuracy which we want to achieve. That could be achieved using hexagons, and maintaining hexagons and figuring and polishing is kind of, the technology is well demonstrated, for example in the Keck mirror technology. So, the Keck segments were also hexagon. So, since technology and polishing and figuring of such hexagons has already been demonstrated, so in case of 30-meter telescope also.
I have a additional question to what my friend did ask out here. And you also pointed out that there is a telescope which is already there, that's the Keck telescope, which has a hexagon mirrors, which has this hexagon mirrors. So, what is the unique point about TMT, since we are using the same technology, and is it the segmented mirrors? Does the
segmented mirror is one technology, and it is the main thing which we are achieving using the same technology which was demonstrated in case of Keck telescope, is that instead of 10-meter equivalent, we are going for a 30-meter equivalent.
Okay.
And that is making a big difference.
So, the size is huge.
Size is huge.
And once the size increases, the parameters and the challenges will also increase.
Right.
So, that's what the uniqueness about
Yes.
this project is.
TMT
yeah,
telescope
yes.
is roughly 10 times as powerful as the existing largest telescope, which is Keck telescope.
Yes.
So,
Okay, now that's interesting.
So the light gathering area of this TMT emitter telescope is roughly 650 square meters, whereas for Keck it's roughly 75 square meters. So that's the comparison.
And also the technology which we are using in case of 30-meter telescope, it's the adaptive optics technology which will be
Well, yes, definitely. Adaptive
dominating.
optics is something which we'll talk about. But let's first go back to the audiences. Any other questions as far as this side? Yes, I have a hand out there. Yes, we'll pass on the mic.
I have a question regarding backend instrumentation. You said that we get information from these backend instruments. So, can without using backend instrument, is this data useful for us if we are not using any backend instrument?
Why is backend instrumentation important, Mr. Kumar?
Analyze the data, you cannot get anything readily by just seeing the sky. So you need to go and analyze the data to get the hidden information. For that, it's necessary to record all the data while telescope is observing, and later on you can do the analysis part on the data to get the useful information from that.
Okay, great. Any other question, please? Yes, I have a hand out there. Yes, in the back.
Hello, myself Mukesh. As it is going to be the largest telescope, so far we haven't got this kind of bigger telescope yet. So apart from the physical answer that we will be observing the fainter objects, what kind of physical mysteries that we are going to disclose with it that we haven't been able to know about the universe so far with the pre-existing instruments?
Okay, Dr. Pandey.
So, with existing telescopes, as you know, that Keck and Hubble space kind of telescopes are the most frontline telescopes that we have, along with those backend instruments which we are using along with these existing telescopes. With the help of TMT and the first generation backend instruments, we plan to answer almost all the questions which are unanswered with these existing facilities. For example, the early universe, the observational cosmology, how stars are evolved, how galaxies were evolved, what is the chemical composition of our Milky Way, what are stellar explosions, what is the extreme physics behind it. So, these are some broad questions which hasn't been answered so far accurately.
So, it's basically to go ahead and answer those questions which have been staring at us for quite some time now. Let's take a short break out here, but when we come back, we will continue this conversation between the panelists and the audiences. There are several interesting questions which the audiences has. There are some questions which even I have, and there are certain specific issues such as the issue of adaptive optics and other questions related to astronomy and TMT. Stay tuned. Welcome back. We are in Aries Institute in Nainital, and the conversation on the issue of astronomy as well as the 30-meter telescope is still on between the panelists and the interesting mix of audience I have. let me once again go back to the audiences. Before we went into the break, there were several hands which were raised, and I'm sure that there are several questions which are to be asked. Yes, whom should we go to first? Yes, yes, my friend out there.
My question
Yes,
is for
please.
Shashi sir. As you said that we are using a bigger telescope so that the light gathering power of the telescope can be increased, and hence the probability of getting a photon detected also increases, and we get a brighter image of that star that is far away from us. So, but earlier when the detectors were not so efficient, we were bound to use bigger telescopes because the quantum efficiency of the detectors were not so good. But nowadays we have CCDs, charge coupled devices, and their efficiency could be reached up to 90%. So can't it be done that the efficiency can be further reduced so that the need for a bigger telescope can be considerably reduced?
Okay, now to put it in simpler terms, since there are so many scientific terms used in that, to put it in simpler terms, what I understand my friend wants to know is that since the efficiency of several other allied things has increased quite many-fold, the need for bigger telescopes. Why the need for bigger telescopes? Why do we need to make a 30-meter telescope with a 30-meter radius when our technology is that much advanced? Can't we do it with a smaller telescope?
No, like you said that the quantum efficiency of CCDs could be as high as 90%. Even if you use that kind of detector with telescope like 10-meter class, then also you are able to see questions which could be answered only when if you have a rather detector much better and with a telescope which is having a much higher diameter.
Okay, Dr. Anil, would you concur with Dr. Pandey?
Yeah, I can say that सितारों से आगे जहाँ और भी हैं, so we do not know what is the limit, what is the limit of the universe. So if we are increasing the sensitivity of the detector, that's fine, but we have to increase the size of the telescopes also, and after some time I think for example this Hubble Space Telescope, it is more efficient because the observations are not hindered by the atmosphere. So this 30-meter telescope definitely will affected by our atmosphere, but after some time probably we have to go outer to get better detector and better the detectivity of the fainter objects as well as the distant objects. So we do not know what is the limit of the universe.
Okay, so I'm sure that we'll keep on improvising based on our knowledge, based on the opportunities which are presented to us, and based on the research which we do. Yes, any other question, please? Yeah, yes, please.
Particular area it is contributing in the TMT.
Can you please repeat your question?
In which particular area it is contributing in TMT?
Okay, specific question with regards to Aries and TMT, as to wherein as far as TMT project is concerned, Aries is contributing. Dr. Wabuddin, can I bring you in here, please?
Because this is a very ambitious project, and Aries is actively participating in this 30-meter telescope, and we are working in so many work package, and segment support assembly, this is one of the important work package in which Aries is taking lead. We are also participating in other work package in collaboration with IIA and IUCA, and many work packages. So this is really a very ambitious project for all our engineers and scientists.
Let's see whether what kind of questions our friends from young friends from the 11th and 12th standards out here have for us. Any questions? Yes, I have a hand out there. Can we have a mic, please?
What resources do India have that it has been included in such a big project among such big nations, both natural and human resources?
Okay, great. Now again, we're going back to the TMT thing. Yes, Dr. Pandey, can we?
Yes, India, it's a kind of developing country, and we have a very good heritage about astronomy, especially the optical IR astronomy. We have optical telescopes since last 50 years. Indian scientific contributions is also considerable. We have lot of industries and we have lot of manpower. For example, in optical IR astronomers in the country are around some 300 to 400. So that number, with that number and with our zeal and curiosity about astronomy, we really need to get involved in a certain project. And internationally we have been offered to get involved in one of those projects, for example GMT, TMT or EELT, just because of our resources, and we have manpower, and we have established some heritage in study of astronomy or instrumentation, or we have industries which could contribute to those kind of projects in a cost effective manner.
This is a very great opportunity to develop high precision technology in our country.
Wonderful. A great opportunity to ensure that we have this technology in our country which can be later used. Yes, any other questions, please? Yeah, please, why not? You're most welcome.
This is something away from the topic.
Well,
I would like to know how much time would it take for people from Earth to go and settle on the moon? One. Secondly, could you tell us something more about the Mars mission that we have sent?
Okay. As far as Mars mission is concerned, I guess that is a question which can be directed to the guys at the ISRO. But as far as the first part of the question is concerned, it's a very interesting question, and I'm pretty sure that most of us have that question in mind. Can we take a wild guess out here?
Yeah, I mean,
all of you are senior scientists. I would not pose a question to individually either of you. Anyone who wants to go ahead and.
So, manned mission for moon is already under consideration by big agencies like NASA and ESA, and you already know since Neil Armstrong era that people have been there. But your question is precisely like whether we would go and some build colony or something would start living there or not. Something is going on. For example, moon's 40% mass is like in form of silicon and titanium dioxide. So, the idea is that somehow on industrial scale, if you can extract oxygen out of it, right, then it will not only be used to make a concept or rather practically think that how we can build colonies, but it would be also helpful to refuel those rockets which are planned to be flown to Mars once they will land to moon,
So
refueled,
we can have a stopover in between where we can sort of push through, give another push to our technologies. This will obviously be really important.
So study is going on, and people are very seriously working about it, that once it is very easy to extract oxygen on industrial scale, then refueling and kind of building colonies and thinking about that in a much kind of systematic way would be possible.
Yes, any other questions? Okay, I have my friend out there. Can we have the mic, please? Extreme right. Yes, if you can stand up and ask a question, please.
My question is that in what has India pioneered in the field of astronomy?
Okay, what has been India's achievements as far as the field of astronomy is concerned? Dr. Anil, I'll like to bring you on this.
This is a very good question in the Indian perspective, and I am happy to say that you mean the first what India has. So, for example, that in way back 1977, the rings of Uranus were discovered, and before that the only planet which was known to have the rings, it was the Saturn, and it was very clearly visible through the telescope, and our observations contributed in detection of the Uranus ring for the first time.
So we have been actively involved as far as movements of celestial objects, recording their movements, recording the phenomena is concerned. Yes, any other question we have?
My question is for Sasi sir. Sir, as you said, you are using adaptive optics technology. So what is this? What is adaptive optics technology?
Okay, wonderful. One thing which we would, which you in fact pointed out before we went into the break.
Yes.
What is adaptive optics? Why is it important?
Okay, adaptive optics, you know that any radiation coming from any celestial object, let's say example of electromagnetic spectrum, electromagnetic wave, and that is supposed to be a plane wavefront if there are no distortions. But once the light from celestial objects, they enter into Earth's atmosphere, due to turbulences and temperature difference and so on, the plane wavefront get distorted. Idea is to somehow get this distortion in the plane wavefront corrected. So that's what you do in adaptive optics, that you throw a laser light and you create an artificial star, and you simultaneously observe a star, real star in the sky, and using some technology called deformable mirrors and cross calibrators, you kind of try to cross calibrate, and once you apply those corrections in the segmented mirrors and you kind of synchronize them in such a way which is synchronous to what kind of distortion you are getting at the moment you are observing.
So Dr. Pandey, in layman's term, what I understand is that it's because of the adaptive optics that we are able to look at the clear picture through telescopes.
Yes, much clearer.
Look at the image is much more clear. We are running a very short of time. Before we come to an end, can we have one last question? Anyone who is interested? Yes, I have a hand out there. Can we pass on the mic? This would be the last question, please.
Overall cost of 30-meter project cost and India's contribution in the overall cost in that.
Okay, what's the cost of the 30-meter project, the 30-meter telescope project?
All right. So the overall cost of the 30-meter telescope project is around $1.8 billion, and India's contribution is at the level of 10%. So the 10% in the cost book, which is given with all kind of escalation and so on, and with a dollar rate of a certain amount, India's contribution at the level of 10% is around 1,300 crore rupees.
See, my question, I think India is not contributing all in cash.
No, that out of that,
it's in terms of technology, it's in terms of
it's in kind and in cash contribution.
It's formation. So obviously it's a huge project, so it's going to cost a lot, and we are moving ahead, so the cost might escalate as well. But apart from the costs, TMT project seems to be a very golden opportunity for India and its scientists to go ahead and participate in this global affair. Wherein we are trying the humankind or the mankind is trying to achieve another milestone in the field of astronomy, to look beyond what we can actually see in and try and find out as to what is it there in the universe, try and find out our actual position in the universe, where do we stand, where does Earth stand, and is there anyone else out there as well. So all these big questions are yet to be answered, but the projects such as 30-meter telescope projects are one of those steps which are being taken by the scientists world over, including those from India, to try and find the answers. We'll come back next week again with a different project, with a different issue, different topic, with a different sets of panelists and a different set of audiences, and definitely a different and a beautiful location once again. Till then, keep watching Rajya Sabha Television.